let's look at example number 7. A little bit change of gear. We did two cell classification problems. This one is about the vertical effective stress. So the question is asking for the vertical effective stress at the bottom of the clay layer. We have 3 layers over here. We have sand, we have a dry sand, and we have a saturated sand layer, and we have a clay layer. So basically, the question is asking for the vertical effective stress at the bottom of the sand. As usual, you can pause the video and try to work on the problem for a couple minutes, and we'll be back with the solutions. Okay, so now we're back. Uh, well, calculating effective stress, total stress, and pore pressure is one of the most fundamental topics in soil mechanics. Uh, we have some equations from the reference manual. You can take a look at it. This is for the vertical stress profiles. Uh, some equations that are pretty sure pretty familiar that total stress minus pore pressure is the effective stress. You have different profiles. You have the height. You have the unit weight. If it's dry, then the total stress. Oh no, if it's doesn't matter whether it's dry or wet. Total stress is always the unit weight of that material time the thickness of that layer. And if you have a saturated layer, you have a gamma 2, then the gamma 2 is a saturated unit weight, then the total stress is basically the summation of gamma 1 H1 plus gamma 2 times H2. And you can calculate the pore pressure, and also the difference between the total stress and the pore pressure would be the effective stress. So, well, that's one way to do it. And if you still remember it, there's a definition called there's a terminology called effective unit weight. And we would sometimes use gamma prime, or most time use gamma prime for that. And the definition of a gamma prime is the saturated unit weight minus the unit weight of water. So a lot of times you can just use the gamma prime for saturated layer to calculate the vertical effective stress. So there's another scenario that, of course, is not this problem, but we're talking about the vertical stress profiles with a surcharge. So if you have a surcharge that is applied on the soil layer, and then basically you just get that surcharge and just apply that surcharge onto the total vertical stress sigma, and the surcharge won't affect the calculation of pore pressure, so that surcharge will also be translated or transmitted to the effective stress as well. But again, so there's assumption that this surcharge should be relatively wide, and kind of you can consider this surcharge as another layer of soil with a approximate this with appropriate depths to generate that enough of the stress on the contact point. So because we're not talking about a point load or a line load on a soil, like you have a P over here, then the increase of the delta sigma prime at any point is not that pressure you would have on the ground. You would have to use the charts and some equations to calculate that. So, but here we're not talking about the scenario. We're talking about a relatively extensive surcharge, and yeah. So okay, well, anyway, so you have those equations, you have those profiles, but again, if you want to save time, I think it's always a good idea to just to remember all those equations. They're super simple to use, and the goal is for you not to have to use those two profiles when you calculate problem like that, because it's really, really fundamental. But anyway, so this one is a little bit tricky. We can look at this together, and I'm just gonna go ahead and use the just to directly calculate the effective stress, because I feel like, again, you would only have a very little time to work a problem like this during the FE exam. So you probably want to be as efficient or as fast as possible. So let's look at the first layer. The gamma is 115. It's dry. So the effective stress right over here is basically 115 times 5, right? So 115 PCF times 5 feet. So we're talking about 575 PSF, pound per square foot. And the second layer, right over here, on top of that 575, you have a sand layer, but the saturated unit weight is 110. And again, we want to use the gamma prime. The definition of gamma prime is gamma SAT minus gamma water, and that is 110 PCF minus 62.4 PCF, which is 47.6. So that is the effective unit weight for that sand. So you have the effective unit weight, and you only have 2 feet. So the effective stress at this depths would be 575. That's how much we get from the last layer, and plus 47.6 PCF times 2. So that's the total PSF over there. Okay. So, and this, how much is about 95.2 PSF. I'm not going to calculate this because, the question is asking for the bottom of that clay layer. So for the clay layer, this is a little bit tricky because you are not given the gamma SAT, which is really the parameter you need to calculate the effective stress. Instead, they give you the GS and the void ratio. So there are a couple ways you can do it. You can plot a 3-phase relationship and do it that way. But if you don't want to do that, you can actually find a definition of a gamma SAT from the reference manual. That the gamma SAT is actually the GS times E plus 1 over E times gamma water. So again, you can easily get this equation if you plot a 3-phase relationship. But if not, just go and get that equation. So this is basically one extra step to come up with the vertical effective stress. But anyway, we have the GS 2.7, we have the E 0.9, we have 1 plus 0.9, gamma water in PCF is 62.4 PCF, and the saturated unit weight is 118.2 PCF. Okay, so then the total vertical effective stress at this point would be 575 plus 95.2. Those are the effective stress from the first 7 feet. And you have the gamma SAT, the gamma prime for that layer is 118.2 PCF minus 62.4 PCF. Then you would have about 55.8 PCF, right? And plus a 55.8 times 10 feet. So, and all those three together, the answer is about 1228.5 PSF, pound per square foot. So the answer is C. So yeah. Oh, that's pretty much about it for problem number 7. Again, this is you know, instead of giving you a gamma SAT, this probably a little bit what I call a cheap shot, but it's just not that bad. Okay.